Hi there, this lesson will be on integration by parts for Calculus 2. So let's start with something that we know. We're going to start with the product rule from Calc 1. So we saw that if we wanted to do the derivative of a product u times v, where both u and v are functions in terms of x, we know that we do basically the derivative one at a time. So maybe we leave u alone, but here we did the derivative of v, and then plus, leave v alone, and then do the derivative of u. So that's just our basic product rule from Calc 1. So what we're going to do right now is integrate both sides. So we're going to say the antiderivative of each piece of that product rule, because we can anti-differentiate term by term. Okay, so now I have this antiderivative. Well, an antiderivative of a derivative is just that original function itself. So the left-hand side will just be the product u times v, which makes sense because in the beginning we were taking the derivative of that product. So once you do the antiderivative, you end up with that product again. And I'll just copy down the right-hand side. Okay, and then all I'm going to do is just solve for one of these antiderivatives. So just for right now, we're going to solve for this antiderivative of u dv. So it's going to look like I will subtract the antiderivative of v du dx from both sides. Certainly not so that I can combine the left side together. In fact, I cannot. So there is my by parts formula. By parts is sort of a way to, if you'll think of it, maybe undo the product rule. But when you do your by parts formula, it is very important that it is just two parts. Okay, so your challenge is going to be to find which part of the original integrand is u and which part is dv. So one piece you're going to have to differentiate, and the other piece you're going to have to integrate. So certainly we should remember from Calc 1, some functions were maybe easier to differentiate than others. Some functions then are a little harder to anti-differentiate than others. So here's sort of a guiding rule of thumb. Again, this is an integration technique, so it's not necessarily a one-size-fits-all, but your new integral should be easier to integrate than the original, or it should be working its way and you should be kind of seeing a path if you pick the correct u. So this is sort of a general rule of thumb. I'll just call it liate, and it's your order to try for who is your u. So as you go through these problems, you're going to want to determine one part to be u, that piece you're going to differentiate, and one part to be dv, and that part you're going to integrate. So you're going to have to be careful and probably go a little slower than what's comfortable because you're going to be doing half integration and half differentiation within an integral problem. So this liate tells us who should be my u. And this is just a general rule of thumb. Just try this order first. It's a lot easier to do the derivative of a logarithmic or natural logarithmic function versus doing its antiderivative. So I'll show you a couple examples with that. Same thing for inverse trig. It's often easier to differentiate than it is to integrate. So this is the order in which I will try for who is my u. A stands for algebraic, so polynomial type functions. T, trigonometric, because some of these, for example, sine of x, might be equally as easy to differentiate or integrate, and exponential, things like e to the x, 2 to the x, etc. Okay, so let's go through a couple examples so you can see what we're kind of talking about here. So when you look at this, you want to find this integral right here, the antiderivative of x squared natural log of x dx. You want to identify two parts. You want one part to be a u and one part to be dv. And then we're using our biparts formula, so that antiderivative of u dv will just be the product of u times v minus the antiderivative of v du. So again, all of these are functions of a single variable, in this case, my example number 1, all with respect to x. Okay, so the two parts that I'm going to identify, if I think about Liate, that's kind of the order in which you should pick your u. Again, it's a lot easier for me to do the derivative of natural log of x than it is to do the antiderivative of natural log of x. So I'm going to go ahead and say u is my natural log of x function. And therefore, everything else that's in my integrand, unless it's a constant coefficient that you pull out front, everything else in your integrand needs to be your dv. So this x squared dx is my dv. And if you look across, so the way that I write this here, you're going to have your own organization system possibly, but when I look across, this is my entire antiderivative, or my entire integrand represented here. Okay, so if I have u, I need to do the derivative, so I'm going to say du. So the derivative of natural log of x is 1 over x dx. It's very important that you have that dx in there. And then the antiderivative, because if you have dv, now you need to calculate v. So I'm going to do the antiderivative of x squared dx. So that just gets me the 1/3 x cubed. I will put my plus c at the end of my overall problem. Okay, so now if I'm looking at my biparts formula, I just have that product u times v. So if you set all these problems up the same way, you're going to find that your product always occurs in the same places. So for example, my u times v is always on this diagonal, and then minus the antiderivative of v du. So that's how mine is always going to look. So this antiderivative of x squared natural log of x dx is u times v. So it will be natural log of x times 1/3 x cubed. I may rewrite that here in a second. So it's my u times v minus the antiderivative, now go this way, v du. So v is 1/3 x cubed, and du is 1 over x dx. Without that dx, you don't know who you're integrating with respect to, and so when you get into multivariable calculus, you might be a little bit in trouble. So you need to make sure you're very clear that your du has that dx in it. Okay, so this first term here is done for me. I'm going to write this out. I am going to write, though, this 1/3 x cubed as a coefficient of natural log, so I don't accidentally multiply those x's together. So something like so, because then a lot of people don't write parentheses. And then I can pull out this 1/3 from my antiderivative here. X cubed over x makes x squared. And I can integrate that hopefully with ease. So my new integral that I'm having to do, right, got easier than my original integrand. And that antiderivative would be x cubed over 3 again, so this will make this 1/9 x cubed plus c. Okay, let's do one more example here. Now I'm going to tackle this one two different ways, just so you can kind of see some options. So the first way I'm going to tackle it is exactly how it looks. Okay, so I'm going to leave it alone and just say that I was told in Liate the very first thing is logarithmic functions. So who should be my u? Well, in the LIATE kind of chain of command there, natural log comes first. So I want my u to be natural log of that function. So then what is the dv? Well, again, if I look across my u and my dv, it has to be the whole integrand. I already have natural log of square root of x accounted for, but look, you don't have your dx anywhere, so my dv just turns into dx. Okay, now carefully, you're going from u, you're going to do the derivative of u. So derivative of natural log of a function is 1 over that function times the derivative of the function. Well, derivative of square root of x is 1 over 2 square root of x, or 1/2 x to the negative half with a dx. I will rewrite that here because this is just 1 over 2x times the dx. Okay, so now on the right-hand side, I have dv, so that means I anti-differentiate. dx, or 1 dx, just becomes x. Okay, so I think I'm ready to rewrite what my new antiderivative will be using that by parts formula. So this antiderivative that I started with will equal u times v, so that diagonal there. And I'm going to write the v in front of the u because otherwise people like to multiply those powers together, and it's really natural log of that function, square root of x, that whole thing times x. So don't change that argument there. So that's your uv minus, this is your by parts formula, antiderivative v du. V is x, du is 1 over 2x times dx. And again, I'm pretty convinced that I can integrate this with ease. So this will become x natural log square root of x minus the antiderivative. Those x's divide to 1. I'm really just integrating 1/2 dx. So then I integrate. So this whole thing is x natural log square root of x minus 1/2 x plus c. Okay, well, I said that I would do this problem 2 ways. What's our other way? So I'm going to completely kind of ditch that here so you can compare and see what you like better. So the other way that I can tackle this problem is I can use my log properties. Well, we probably remember that if we had, log of a to some exponent m, that turned into m times log of a, right? That exponent came down in front, and that's because you're repeatedly multiplying by a. So this is, log of a times a times a times a, m times, and the multiplication turned into the addition of 2 logs because, again, a logarithm equals an exponent. So your exponent rules are very similar to your log rules. Okay, so I'm going to use that log property and just do a rewrite. So what I will see is that I have antiderivative. This is really x to the 1/2. So this is the same thing as 1/2 natural log of x dx. And of course, the 1/2 can come out front if you so choose. I think this problem might be a little bit maybe easier to work with, but in the end, my answers will be equivalent. Okay, so I need to identify how am I going to anti-differentiate natural log of x dx. Well, it's actually a by parts formula, so please don't memorize what this antiderivative is. So your u is going to be your natural log of x. So then your dv is all of the leftover, which is dx. Now, one piece of caution to you is that if this 1/2 is going to be left off your problem, if you are going to forget about it, put it in front of your u. So make your u be 1/2 natural log of x instead of just natural log of x. So be careful that you don't lose that 1/2. I'll just kind of highlight it and keep an eye on it as I go. So if u is natural log of x, I'm going to do the derivative of u. Derivative of natural log of x is 1 over x dx. And anti-differentiate dv. So v, well, I'm anti-differentiating dx, so that's just x. All right, so this antiderivative equals, so my original. Okay, now I don't want to forget this 1/2. So I know this antiderivative is going to equal 1/2 times, here comes my by parts formula, u times v, so it'll be natural log of x times x. And when some people write natural log of x times x, then they think it's natural log of x squared, and it's not. So I like to write that x in front. After all, it's just a product, so I can use my commutative property, which says 2 times 3 is the same thing as 3 times 2. So I'm going to write x times natural log of x. That's my uv minus the antiderivative v du. So v is x, du is 1 over x dx. My new antiderivative is absolutely easier to integrate than the original. So I continue on. And I'm really just integrating 1. So that's just x plus c. Don't forget that half in front. Now, are these two equivalent? And my answer is yes. So certainly I can see that the second term is going to be equivalent because they're both 1/2 x. But look at your first term. Well, again, if you have the x is the same in both, but the natural log is not. So in one you have natural log of x, and in the other one you have natural log of square root of x. Well, remember, if I go through a rewrite here, that exponent can come down in front, and now they look equivalent. You can always throw in some random number as well and check their equivalencies. So this should just get you started with integration by parts. There are far more examples that we can do, but I hope this gets you started with the by parts formula and Liate. So by parts formula being that antiderivative of u dv will be your uv minus v du, the antiderivative of v du, and your Liate, sort of who should be your u. So I hope this gets you started. Thanks for watching.